So let's go over some body cavities. Now obviously we have the thoracic area. Well, the thoracic area has a thoracic cavity, and the abdominopelvic area that we talked about earlier has an abdominopelvic cavity, which is where most of your visceral organs are, other than your lungs and your heart, which are in the thoracic cavity. And basically we can think of the thoracic cavity, and I'll show you a picture of it here, using this book as a reference this time. The thoracic cavity is basically everything contained within your ribs to the diaphragm. Now this is the diaphragm. It's a giant muscle. It's a muscular sheet with a very tendinous portion here. And it's what moves up and down when you breathe. It has a huge range of motion. So when you breathe, you can actually feel it drop and you can feel it rise. And so this shape is always changing as your ribs expand. But typically speaking, and now I'll use this book. This is your thoracic cavity right here. Everything contained within the ribs that's bounded on the lower surface or the inferior surface by the diaphragm. Now, the diaphragm separates the thoracic from the abdominopelvic cavity, but within the thoracic cavity you have two lungs, your heart, and this area in the middle called the mediastinum. And the mediastinum is connective tissues that are between the two lungs, and the lungs have their own cavity called pleural cavities. This is your left and right lungs, and they're contained within pleura. And we'll talk about what pleura are in just a minute. But we have three types of cavities that are bounded by serous membranes. And I'll tell you what a serous membrane is in just a second. But you have the pleural cavities, which surround the lungs, the pericardium, which surrounds the heart, and you have the peritoneum, which surrounds many of your visceral organs in the abdominopelvic region. Now, typically, this whole area below the diaphragm that's bounded by the pelvis, by the bones of the pelvis, is called the abdominopelvic cavity. You can sort of further subdivide this into the abdominal cavity, which is sort of this light blue area up here, and the pelvic cavity, which is delineated by this darker blue area here, and this is just the area that's bounded within the pelvic bones. And then you have this thing called the peritoneal cavity, and it is also, all the organs within it are bounded by this serous membrane. And I don't really want to say bounded by, but are covered in a serous membrane. And the peritoneal cavity covers most of the abdominal cavity and part of the pelvic cavity. So basically you have kind of three overlapping cavities here. You've got the abdominopelvic cavity with the peritoneal cavity that overlaps it, and the peritoneal cavity contains part of the abdominal cavity all of the abdominal cavity and part of the pelvic cavity. Now, what do I mean by a pleural membrane? Well, a pleural membrane is very similar to this Ziploc bag here. You've got, let's just say my hand is an organ. Well, it would be surrounding my hand. And you've got two surfaces, and look at how these surfaces can easily slide over one another. You can see it here in the book. This is greatly exaggerated, but the pericardium is an example of a serous membrane. And so what happens is you have, just like this bag, you've got one part of it that's close to my hand, and that would be, if my hand is an organ, that part that's close to my hand is called the visceral part of this membrane. The external part, the external side, would be called the parietal part. Now, inside this bag, or this serous membrane, is usually a very, very tiny space with a very lubricating fluid that's mostly water, but it slides. It makes the membrane slide very easily. So the visceral part of the membrane can slide right along the parietal part of the membrane, the visceral part of the membrane can slide over one another. And you see this with the heart. Here's your visceral pericardium, and here is your parietal part, and inside of this thing is some fluid. And the fluid makes these things able to slide over each other, that is the visceral and parietal part of this membrane, able to slide over one another with great ease, because the heart's always beating. The lungs are always expanding. You don't want these things to catch on other organs. You want them to have this kind of surface that slides so easily and nicely with very little friction over itself and other surfaces. For example, the heart is going to be right next to the lungs, and each of them have their own serous membranes with a visceral and parietal part, and you can see the space between them is very, very narrow. So technically, when an organ is surrounded by a visceral membrane, what we mean by the pleural cavity is actually the space between the visceral and the parietal part. So that would be this space inside, which usually is not much of a space at all. And unfortunately, what happens is, if there gets an infection in here or some other problem in any of the serous membranes, for example, the pleural membrane, you get pleurisy, and that might make it hard for you to breathe because this small space in here becomes enlarged and starts pressing on the lungs. If you have pericarditis, then you have an inflammation of the pericardium that will press upon the heart, and that can become a problem. So it can impede your heart's functions. So you have this air space, well, it's really fluid filled in the serous membrane that basically allows for, and this actually is an example of the book, and they're using a similar example that I did with the Ziploc bag, but they're using a balloon. And so they're taking the fist and using the fist as an example of the heart, and they're covering it with a balloon. They're having the person stick the fist in the balloon, and they're saying that the part that's close to the balloon, so the balloon has now deformed around the fist, the part that's closest is the visceral part, and the part that's on the outside is the parietal part, and the space in between is the pericardium, is the pericardial cavity. I'm sorry. So that cavity is really basically a fluid-filled space, and it's a very, very narrow space. It's much more like what you would see with this Ziploc bag here. And although this has no fluid in it, it typically would have like a very thin fluid of water, or serous fluid, which is mostly water.